In 1993, scientists stumbled upon a discovery that would challenge our understanding of prehistoric amphibians. It took 14 years of painstaking research to piece together the puzzle, but the result was astonishing. This is the story of Beelzebufo, a creature that defied expectations and sparked a scientific mystery unlike any other. 70 million years ago, in the lush landscapes of Madagascar, an unexpected predator lurked among the dinosaurs. This creature was far removed from the gentle frogs we know today. As paleontologists slowly uncovered its remains, they realized they were facing something extraordinary. The discovery of Beelzebufo promised to reshape our understanding of ancient ecosystems and the capabilities of amphibians throughout Earth's history. Its characteristics suggested a creature that would force scientists to reevaluate long-held beliefs about prehistoric life. What secrets did this ancient amphibian hold, and how would it change our view of the past? While Beelzebufo's existence challenged our understanding of prehistoric life, its true nature remained shrouded in mystery. What dark secrets would emerge as researchers pieced together the puzzle of the devil frog over the next decade? The story of Beelzebufo began in 1993 when the first fossil fragments were discovered in Madagascar. These fragments, unlike anything scientists had seen before, didn't match any known amphibian species. This initial find marked the beginning of a 14-year journey of painstaking research and fossil collection. As paleontologists slowly accumulated more pieces of this prehistoric puzzle, they realized they were dealing with something extraordinary. Between 1993 and 2011, researchers uncovered over 100 fossil fragments, including skull parts, vertebrae, and other skeletal elements. This extensive collection of specimens provided a wealth of information about Beelzebufo's structure and characteristics. The holotype of Beelzebufo, designated as specimen UA9600, consists of a fused cervical and second presacral centra. While this might seem like a small piece of the puzzle, it provided crucial information about the frog's structure and size. Initial estimates suggested that adult Beelzebufo could reach lengths of up to 42.5 centimeters, 16.7 inches, from snout to vent, making it significantly larger than any known living frog. These size estimates sent shockwaves through the scientific community. The idea of a frog reaching such dimensions was unprecedented, and for many, hard to believe. Skepticism arose about whether a frog could truly grow to such proportions. This controversy sparked intense debate and fueled further research into the capabilities and limitations of amphibian physiology. The discovery of Beelzebufo didn't just challenge our understanding of frog size, it also raised intriguing questions about the prehistoric ecosystem of Madagascar. How did such a large amphibian fit into the food chain? What were its prey? And what, if anything, preyed upon it? These questions drove researchers to dig deeper into the ancient Madagascan environment, searching for clues about the devil frog's lifestyle and ecological role. Finally, in 2008, after more than a decade of dedicated work, scientists had gathered enough evidence to officially name and describe their discovery. They chose the name Beelzebufo, which translates to Beelzebub's frog. This name, inspired by the demon Beelzebub from theological sources, reflected the creature's intimidating appearance and formidable size. As news of Beelzebufo spread beyond scientific circles, it captured the public imagination. The idea of a frog large enough to potentially prey on young dinosaurs was both thrilling and terrifying. It sparked a renewed interest in paleontology and prehistoric life, particularly among young people fascinated by the idea of giant, predatory amphibians roaming alongside dinosaurs. While the public marveled at the idea of a dinosaur-eating frog, paleontologists faced a daunting task, reconstructing an entire creature from a handful of fossilized fragments. What they discovered about Beelzebufo's anatomy would challenge everything we thought we knew about frogs, ancient and modern alike. The reconstruction of Beelzebufo from fragmentary fossils was a painstaking process that took years of dedicated research. As scientists pieced together the puzzle, they uncovered a creature that defied conventional expectations of amphibian anatomy. One of the most intriguing aspects of Beelzebufo's anatomy was the evidence of continued growth in adult specimens. Even in the largest fossils found, The skull sutures remained open, suggesting that these frogs may have continued to grow throughout their lives. Beelzebufo's unique bone structures set it apart from modern frogs in several ways. Most notably, it possessed well-developed ribs, a feature typically absent in contemporary frog species. This adaptation contributed to its armored appearance and provided crucial structural support for its large body size. The presence of ribs allowed Beelzebufo to grow much larger than most modern amphibians, as the additional skeletal structure helped distribute its weight more effectively. The locomotion pattern of Beelzebufo was particularly fascinating, bearing a striking resemblance to the Argentine walking toad. This ancient frog likely moved using a distinctive sequence: front left leg, back right leg, front right leg, and then back left leg. This walking style was made possible by ball and socket joints in its legs, a feature that provided greater flexibility and range of motion compared to the simpler joints found in many modern frogs. However, Beelzebufo's locomotion method presented unique challenges. Some scientists propose that it may have relied on dragging itself across the ground, a strategy that posed significant risks. The thin skin characteristic of amphibians made Beelzebufo susceptible to skin sloughing, a potentially fatal condition where the outer layer of skin is damaged or removed. This physiological constraint likely influenced its survival strategies and mobility, possibly limiting its ability to travel long distances or navigate rough terrain. The limitations of amphibian physiology pose interesting questions about Beelzebufo's size and lifestyle. Larger sizes present challenges for locomotion and overall survival in amphibians. Beelzebufo's short legs and body structure suggest it may have relied on ambush tactics rather than the impressive jumping abilities we associate with modern frogs. This adaptation to a more terrestrial lifestyle aligns with its role as a formidable predator in its ancient ecosystem. Visual reconstructions of Beelzebufo depict an imposing presence that would have been a force to be reckoned with in prehistoric Madagascar. Its broad, squat body and large eyes positioned high on its head bear a resemblance to modern Pac-Man frogs, providing clues about its ecological role and behavior. However, its armored skin and massive jaws would have made it a far more formidable predator than any frog alive today. The study of Beelzebufo's anatomy not only sheds light on this particular species, but also broadens our understanding of amphibian evolution and the diversity of life forms that have existed on our planet. It challenges our preconceptions about the limitations of amphibian physiology and raises intriguing questions about the environmental conditions that allowed such a creature to thrive. While Beelzebufo's physical adaptations were impressive, its hunting abilities set it apart as a formidable predator. The devil frog's powerful bite, estimated between 500 and 2,200 newtons, rivaled that of wolves and female tigers. This extraordinary strength allowed Beelzebufo to crush the bones of its prey, expanding its potential food sources significantly. Beelzebufo likely employed a cunning ambush strategy, similar to its modern relatives, the Pac-Man frogs. Camouflaged among the prehistoric foliage of Madagascar, it would patiently wait for unsuspecting prey before lunging forward with its powerful jaws. The devil frog's menu was diverse, including insects, small mammals, reptiles, and possibly even small dinosaurs, placing it at the top of its food chain. One of Beelzebufo's most intriguing adaptations was its tongue and saliva. Modern Pac-Man frogs possess saliva 6 times stickier than honey, a trait Beelzebufo likely shared. This adhesive saliva, combined with a lightning-fast tongue, made escape nearly impossible for its prey. As a top predator, Beelzebufo played a crucial role in maintaining the balance of its ecosystem. It likely controlled populations of smaller animals, influencing the entire food web of prehistoric Madagascar. This impact highlights the importance of apex predators in shaping ecosystems, a principle that holds true from the age of dinosaurs to the present day. Beelzebufo's ecological role can be compared to that of the modern African bullfrog, another large and aggressive amphibian. African bullfrogs are known for their ill-tempered nature and fierce territorial behavior. They fiercely defend their breeding sites and have been observed attacking animals much larger than themselves, including humans. It's likely that Beelzebufo exhibited similar aggressive tendencies, perhaps even more pronounced, due to its larger size and more powerful bite. The devil frog's territorial behavior might have involved aggressive displays, vocalizations, and physical confrontations with potential rivals or intruders. This territorial nature, combined with its predatory skills, would have made Beelzebufo a formidable presence in its habitat, shaping the behavior and distribution of other species in its ecosystem. However, Beelzebufo's voracious appetite may have come with risks. Some modern frogs are known to attempt to eat prey items too large for them to swallow, sometimes leading to choking or other complications. It's possible that Beelzebufo, with its impressive size and powerful jaws, might have occasionally bitten off more than it could chew, quite literally. Imagining Beelzebufo in action is a testament to the wonders of evolution. Picture a frog the size of a beach ball, its armored skin glistening in the dappled light of a Cretaceous forest. Its eyes, set high on its broad head, scan the surroundings for movement. Suddenly, a young dinosaur wanders too close. In a flash, Beelzebufo springs into action, its massive jaws clamping down with bone-crushing force. The struggle is brief but intense, ending with the frog slowly swallowing its dinosaurian meal. As Beelzebufo finishes its meal, a question arises. In a world where a frog could prey on dinosaurs, what creature sat at the top of the food chain? The answer might surprise you, and it reveals the complex web of life in Cretaceous Madagascar. 70 million years ago, Madagascar was a land of extremes. The landscape was characterized by a unique ecosystem that blended rivers and floodplains with semi-arid climates. This environment was subject to brutal dry seasons, creating a challenging habitat for its inhabitants. The island's isolation had allowed for the evolution of a diverse range of species, making it a hotbed of biodiversity, unlike anywhere else on Earth. In this prehistoric playground, Beelzebufo shared its territory with an array of fascinating creatures. Dinosaurs roamed the land, including the fearsome predator Majungasaurus, the long-necked herbivore Rapidosaurus, and the small, buck-toothed Masiakasaurus. Evidence suggests the presence of a stegosaur or ankylosaur. The waterways teemed with fish, while various lizards, turtles, and snakes slithered through the undergrowth. Beelzebufo's adaptations, including its massive size and powerful bite, equipped it to thrive in this harsh environment. Its preferred habitat was likely near bodies of water, where it could ambush prey. The devil frog's armored skin provided protection against the intense sun during dry periods, while its size allowed it to survive longer without food or water compared to smaller amphibians. The ecological role of Beelzebufo was complex. While it was a formidable predator capable of taking down young dinosaurs, it also faced competition and threats from other large carnivores. Crocodilians and giant snakes shared the ecosystem, suggesting that Beelzebufo occupied a dynamic position in the food chain, potentially shifting between predator and prey depending on circumstances and life stage. The unique geography of Madagascar during this period likely influenced Beelzebufo's range and distribution. The island's varied terrain, from coastal lowlands to central highlands, may have created distinct populations adapted to specific local conditions. As the climate fluctuated over millennia, these populations might have expanded or contracted, potentially leading to variations within the species. Recreating scenes of Beelzebufo in its natural environment requires a blend of scientific knowledge and informed speculation. Picture a mosaic of habitats, lush riverside vegetation giving way to drier scrubland, punctuated by seasonal wetlands. In this diverse landscape, Beelzebufo would have been a dominant presence, its deep croaks echoing across the prehistoric night. Beyond its fearsome presence in ancient Madagascar, Beelzebufo presents scientists with an intriguing mystery. Its closest living relatives aren't found anywhere near its former stomping grounds. Instead, they reside in South America. How can we explain this baffling geographic disconnect? The evolutionary puzzle of Beelzebufo deepens when we examine its unexpected relationship to modern frogs. Recent studies have revealed surprising connections that challenge our understanding of amphibian evolution. A 2023 phylogenetic study has placed Beelzebufo as a sister taxon to Ranoidea australis, adding a new layer of complexity to the ongoing debate about its evolutionary relationships. This latest research employed advanced genetic analysis techniques and detailed fossil comparisons to reassess Beelzebufo's position in the amphibian family tree. The study's findings suggest a closer relationship between Beelzebufo and certain Australian frog species than previously thought, further complicating the Madagascar-South America connection hypothesis. The implications of this new research are significant. It challenges the idea that Beelzebufo is closely related to the Pac-Man frogs of South America, as suggested by earlier studies. Instead, it points to a more complex evolutionary history that may involve multiple instances of convergent evolution or ancient dispersal events across continents. However, the scientific community remains divided on the true nature of Beelzebufo's lineage. Some researchers argue for a direct ancestral relationship between Beelzebufo and modern Pac-Man frogs, while others suggest they may belong to a more ancient group of frogs that diverged earlier in evolutionary history. The 2023 study adds another perspective to this ongoing debate, highlighting the complexity of amphibian evolution and biogeography. Alternative theories continue to emerge to explain this evolutionary conundrum. One possibility is that similar environmental pressures in Madagascar, South America, and now potentially Australia led to the independent development of similar traits in distantly related frog species. Another theory proposes the existence of missing links, intermediate species that once bridged the geographic gaps but have yet to be discovered in the fossil record. The implications of Beelzebufo's evolutionary relationships extend far beyond this single species. Understanding how these frogs are connected could provide insights into ancient migration patterns, climate changes, and the development of unique adaptations in isolated populations. It also underscores the importance of continued research and fossil discoveries in refining our understanding of prehistoric life. Ongoing research aims to solve the Beelzebufo mystery through various approaches. Scientists are conducting detailed comparative analyses of Beelzebufo's skeletal structure with both extinct and living frog species. Advanced genetic studies of modern frogs are being used to create more accurate evolutionary trees, which can then be used to infer the relationships of extinct species like Beelzebufo. The potential for future fossil discoveries to provide answers remains high. Madagascar's rich fossil beds continue to yield new specimens, and unexplored areas might hold the key to understanding Beelzebufo's true place in the amphibian family tree. Similarly, new fossil finds in South America, Australia, or even Antarctica could reveal intermediate species that help explain the connection between these geographically distant frog populations. Beelzebufo's discovery has sent ripples through the scientific community, challenging long-held beliefs about prehistoric amphibians. This giant frog has forced paleontologists to reconsider the size limits and predatory capabilities of ancient frogs, leading to a re-evaluation of their ecological roles. The implications of Beelzebufo's existence extend beyond its own species, prompting scientists to reassess the entire evolutionary history of amphibians. The impact of Beelzebufo isn't limited to extinct species. Its discovery has influenced studies of modern frogs, particularly in understanding the evolutionary adaptations that allow for larger body sizes and predatory behaviors. By examining Beelzebufo's close relatives, such as the Pac-Man frog, researchers are gaining new insights into the ecological roles of large amphibians in both prehistoric and contemporary ecosystems. The devil frog has captured public imagination, often referred to as the frog from hell in popular media. This nickname has sparked increased interest in paleontology among general audiences. Its unique features and predatory nature have made it a subject of fascination in documentaries, books, and educational programs, bringing the wonders of prehistoric life to a broader audience. The search for more complete Beelzebufo fossils continues in Madagascar. Paleontologists hope that new discoveries will provide further insights into its size and ecological role. There's particular interest in finding larger specimens to clarify Beelzebufo's true maximum size, which remains a topic of scientific debate. Technological advancements are enhancing Beelzebufo research. Imaging technologies like CT scanning and 3D reconstruction allow scientists to analyze fossils more thoroughly without damaging the specimens. These tools enable paleontologists to visualize Beelzebufo's anatomy in unprecedented detail, offering new perspectives on its structure and potential capabilities. Beelzebufo's existence offers important lessons about biodiversity and evolution. Its unique adaptations highlight how isolated ecosystems can lead to the development of extraordinary species. By studying Beelzebufo, scientists gain insights into the evolutionary pressures faced by amphibians in isolated environments, contributing to our broader understanding of how species adapt and evolve over time. The search for Beelzebufo's living relatives or descendants continues to intrigue scientists. Its distinctive features suggest a complex evolutionary history that may still hold secrets about amphibian lineages. This ongoing research could uncover more about the evolutionary pathways of amphibians, potentially revealing connections between prehistoric and modern species that we've yet to discover. Beelzebufo's evolutionary secrets aren't the only mysteries surrounding this ancient frog. Its hunting prowess has sparked intense debate among paleontologists. Could a frog truly dominate in a world of dinosaurs, or are we overestimating its capabilities? To answer this question, we need to compare Beelzebufo to other prehistoric predators. While its size and bite force were impressive for an amphibian, they were not unmatched in its ecosystem. Beelzebufo's bite force, estimated between 500 and 2,200 newtons, was formidable but still less than that of larger dinosaurs and crocodilians of the time. Beelzebufo's strengths lay in its unique combination of size, powerful jaws, and amphibian adaptations. Its large mouth and strong bite would have allowed it to crush bones and overpower smaller prey. The positioning of its eyes high on its head suggests an ambush predator lifestyle, similar to modern pac-man frogs. This strategy, combined with its potentially sticky tongue and adhesive saliva, would have made it a highly effective hunter for its size. However, being an amphibian also came with limitations. Beelzebufo's need to stay hydrated and regulate its body temperature would have restricted its range and hunting capabilities compared to some of its reptilian contemporaries. Its short legs and heavy body suggest it wasn't an agile hunter, relying instead on ambush tactics. The debate on Beelzebufo's role in its ecosystem remains open. While it was certainly a formidable predator within its size range, it likely occupied a specific niche rather than ruling over the entire food chain. Its ability to prey on smaller dinosaurs is plausible, but it would have faced competition and potential predation from larger carnivores. Expert opinions on Beelzebufo's capabilities vary. Some paleontologists emphasize its unique adaptations, while others caution against overstating its dominance. This debate highlights the challenges in reconstructing the behavior and ecological roles of extinct species based on limited fossil evidence. Many questions about Beelzebufo's behavior and life cycle remain unanswered. How did it reproduce? How long did it live? Did it undergo metamorphosis like modern frogs? Or did it have a more direct development? These uncertainties remind us of the limits of our knowledge when studying prehistoric life. Imagining encounters between Beelzebufo and its contemporaries requires a balance of scientific evidence and informed speculation. Picture a Beelzebufo waiting at the edge of a watering hole, its eyes barely breaking the surface. A young dinosaur approaches to drink, unaware of the danger lurking inches away. In a flash, Beelzebufo lunges, its powerful jaws clamping down on its prey. But the commotion attracts larger predators, forcing the frog to retreat with its meal or risk becoming prey itself. Beelzebufo stands as a testament to the extraordinary capabilities of nature and evolution. This prehistoric giant challenges our understanding of amphibian potential, showcasing the remarkable diversity of life that has existed on our planet. While Beelzebufo's reign ended millions of years ago, its legacy continues to inspire scientific inquiry and fuel our curiosity about Earth's past. The study of Beelzebufo offers valuable insights into the adaptability of species and the complex interplay of environmental factors that shape life on Earth. Its existence prompts us to reconsider the limits of amphibian evolution and encourages further exploration of prehistoric ecosystems. As we uncover more about Beelzebufo and its contemporaries, we gain a deeper appreciation for the remarkable adaptations that have emerged throughout Earth's history. This ancient frog serves as a powerful reminder of the incredible diversity that has existed on our planet and the potential for future discoveries to reshape our understanding of life's evolutionary journey.